I just had to do a couple more diagrams. I'm not sure.
Okay, so let's have a look at the concept of Venn diagrams just in total, especially that particular formula, the probability of A plus the probability of B. Now, suppose I've got my sample space, which is a rectangle, and I've got some event A, and then I've got some event B, which overlaps with A. That means there's a double counting happening in the middle. So I've got A over here, and I've got B over here, and I've got some kind of double counting happening over there. The first thing we have to also understand is that this region over here is known as the probability of A and B. And that's also known as the intersection of the two. Okay? And then the probability of A or B encompasses everything all the way across both of them. The probability of A or B encompasses everything over there. All right, which is the orange part. And then the region on the outside would be obviously not everything. So the outer region there will be, I'm using probability. You could also use n. And when you use n, A and B, n just stands for the total number of items in there. Okay, so counting. This is more counting. Probability is a percentage, right? So the probability of A or B, but it's not that, right? Because it's the opposite. If it's all there, and if it's not that, then it's everything around it. Right? Everything around it, which I'm going to put in red. Okay. So that's the probability of it not being in that space. The next thing is if I look at it individually, I can see this here is the probability of A.
Mm.
And this part over here is just the whole of B, probability of B. Now, the intersection is where they overlap. If I have a diagram where I'm saying that I'm just including this part here, which is the probability of A or B, it's going to be equal to firstly the probability of A plus the probability of B, right? And what you notice is if I take two circles and I put them over each other. So let's look at two colors. What two colors get you a certain color? I think it's two prime colors: red, green, and red, blue, and yellow. Gets you green or something. Blue. If I put a blue
RGB.
circle, yeah, I put a blue circle over here, and I put
Red.
a yellow circle on this side. Okay. Anyway, they're overlapping, and there's a
Red, blue, right?
yeah. But there's a definitely a double counting there. Can you see that? Okay. So if I remove that double counting, that means I have to subtract it from these two. Okay, so this is A and this is B, and now double counted. So I need to minus one of these layers. And remember that layer is A and B. So I need to minus that layer just once,
Blue.
because that's going to be the intersection of the two events. And we can see
You
that
subtract it from both, right?
I'll end up with, so we're subtracting it from the sum of both, which ends up over here. But let's look at it in terms of a set now. Let's suppose I've got this set of A, which is 1, 2, 3, and 4. Let's look at set B, which is 4, 5, 6, and 7, right? Now, A or B, we can tell quite clearly what's in A or B. 1, 2, 3, 4, 5, 6, and 7. That's in A or B.
You got 2 4s there as well.
And I don't need to put 2 4s because it's the same thing, right? It's in either or. So if it's in this one, I just need to add it once. It's in that part there, right? If I take A or B, you can see it's equal to A plus B minus the 4, right? The extra 4. Now, what is A plus B? That's a different idea. This is where you have the repeated part, right? So A plus B is going to be 1, 2, 3, 4, 4, 5, 6, 7. But A union B removes the repetition, right? So if I want to find out A union B, which is this part here, it will equal to A plus B, which is that, minusing the intersection. And what is the intersection? What is A and B? That is the set 4, which is also known as intersection number. So I have to minus A and B once. And the result of that will be A or B. So what am I saying? I'm saying that this is equal to this plus this, which is that actually, minus the intersection of the two. Okay, so I'm minusing the intersection of the two, which is going to be that part there. Okay? All right, so that's where the total number of A or B is equal to the number in A plus the number in B minus the number in the intersection of A and B. The probability of A or B follows the same trend. Probability of A plus the probability of B minus the probability of A and B. So if I'm given some event A, which is equal to 1, 4, 7, and 8, and I'm given B, which is going to be 4, 8, 12, and 15, and I'm asked to find the probability of A or B, or the total number in A or B, or just A or B, I'm going to have to take A plus B minus the intersection of it. Now, what is the intersection of these two? It's where they overlap. In this case, it's 4 and 8. So this is going to be added together. I'm going to get 1, 4, 4, 7, 8, 8, 12, 15. And then I'm going to subtract 4, 8 from there, which means I'm going to just remove the repetition. In other words, I'm going to have 1, 4, 7, 8, 12, 15. And this is the set that is found in A or B, not repeated as well. Okay, keeping that formula in mind, let's look at the different representations now of using the prime component in it, right? So let's look at not A and B, etc. Maybe I can do one big, okay, or one big one small one. Do a few. All right, in each of these, I'm going to put 2 circles in. Then I'm going to shade each one, and we're just going to show different kind of possibilities of Venn diagrams where you're including intersections and primes in the way it is through set notation shown. Okay, so it's populating each of these quickly. All right, here we go. So I've got A over here, B over here, and I want to find out what is this region over here. Okay. Now I can see that this is where it could be not B, right? Definitely not B there. But it's also A at the same time. Can you see that? It's not B.
A and not B.
It's not
Right.
B and A. Yeah, because A, remember, will be, if this was A and B, A will be this whole region. Not B would be everything around it, and they would overlap exactly in that spot. Okay. Then we look at this region over here, which would be, and this you can write the other way, A and not B. This one is not A and B, right?
Yeah.
Then we look at the region around the Venn diagram. And remember, that's everything that is not that, right? And what is that? That is A or B. So it's not A or B. This one here is going to be not A or B. So you find A or B and you just find not A or B. The next part is over here. So this is A and B. I mean, we know this one. This one's easy. This one's A and B. Okay, that's just the intersection. And we know also that that's the union, A or B. And if I have to just choose one of them, like that, then that should just be A. Or, you know that, that's easy. I have to choose everything around this part. Yeah. That'll be not B. We can also write this in other ways. I mean, we could rewrite this. Now, the next thing I would like to find out is, okay, well, if I'm given not A or not B, what would that look like? Or if I've got not A and not B, what would that look like, right? So how would I go about drawing the Venn diagram and shading exactly that in? So I'm going to get the circles in there. All right. So not A or B is what we want to find. What I'll do is I'm first going to represent not A quickly, like this. I'm going to sketch it here, and I know not A is going to be that whole region there. Then I'm going to sketch not B, which is actually that whole region over there. And I want to see where they overlap. And they
So they
actually
overlap on the outside?
they overlap everywhere except in the middle.
Yeah, everywhere except for one.
So they would overlap. So if I had to shade this region in, it would be everything except that central space there. Over there. Okay. The next one is not A. So this is A. So not A is again that space there. Actually, it's the same thing, right? It's the same thing. So I won't have to redraw it, right? Where are they overlapping? Where do they overlap? Is the question. Where do they actually cross each other at the same time? Not A and not B at the same time. It would be, can you see in the space outside of both of them?
So they don't overlap in the middle.
So on the outside, it would be not A and not B at the same time. That makes sense also because it's not inside A or B and B at the same time. All right?
Yeah.
So that's not A and not B, and this is not A or not B. So you have the ability to have one at a time, and you have the ability for them to overlap. Whereas this one, only overlapping allowed.
Mm.